Hello everyone, I hope you all are doing well. I had good lunch. I myself feel a little dizzy after a heavy lunch in my tummy. So I'll try to keep things as interesting as possible. So a bit about me. People call me Ameer and I work as a tech lead at HackerRank. I lead the ID team. So the responsible of the ID team is to, uh, you know, make sure all the IDs that you see in the HackerRank products are as developer friendly as possible, and add HackerRank specific features into it, like for example collaboration and other interesting tech challenges that we have on the ID space. So that's what I pretty much do on a daily basis. And today I'm really excited to talk about collaboration. I know that like most of us got into collaboration when we saw Google Docs, and I myself felt it was some kind of black magic, and I thought like building such applications is going to be really difficult and it's not going to be straightforward. But after we built collaboration for HackerRank product, I made a realization that it's not that difficult at all. Um, so here I am to share some of the learnings that we had while building collaboration into HackerRank products, right? So some of you might have an obvious question on like, but why, right? Like collaboration could be a good to have feature, but it's not a must to have feature, right? And like collaboration can be something last on my roadmap. But in today's remote first world, that has changed. Almost every application that you use today, even the terminal, has brought in collaboration, right? Like I guess some of you might be using the WAP terminal. So almost every application that you are using today has some kind of collaboration built into it to enable remote collaboration. So collaboration is becoming more of a core feature to some of the products that are right there, and it's becoming a must to have feature for a lot of products out there. Some obvious example, if I take Google Docs, imagine like working with your friend on a Google Doc without collaboration, right? Unimaginable. Figma, like the entire idea of Figma itself is to collaborate on design, right? And in HackerRank interviews, when you're giving an interview to an interviewer, you want you and the interviewer to collaborate on the same code, right? So one of the biggest feature that when Trello came out was like you can see in real time, like who's updating the board, who's working on what, and who is updating the wallpaper and stuff like that. And or an escalator, right? If you have something in your mind, you want to put the design to paper and you want to collaborate on with your friend, you just share a link and there you are collaborating on the design that you had in mind, right? So with this, I guess I might have brought you to the edge of the seat, but just to prove my point on like how simple it is to build a collaborative application, I have a small example over here, which is kind of a collaborative to do. So like for example, I can add a to do. I have opened the same window into another browser object, and you can see that like it is getting reflected on both sides, and I can do the same on the other window. Um, Give me a second. Sorry for that, folks. So yeah, so you can see a simpler collaboration of to-dos, right? And you can see that I have created a simple hook. We'll go through the hook, but this hook gives me a to-dos and a way to add the to-dos, right? As simple as that. And this, trust me, this hook is not more than 20 lines of code, right? So before I take you through the code and show you like how the code looks like, um, I want to take you to the back seat and see like behind the scenes what is happening, right? So there are two major algorithms which drives this. There are many algorithms, but these two are the most commonly accepted and widely used. One is called operational transformation or OT. Another is conflict-free replicated data type or CRDT. I know the title sounds very scary, but trust me, the actual algorithm is pretty straightforward and simple than it sounds, right? So before we dig deep into it, big disclaimer: it's pretty simplified. I'm kind of keeping it very simple, avoiding a lot of nuances, edge cases that are part of the algorithm. I would highly recommend going through the white paper of the OT and the CRDT to know more. So yeah, all that I'm sharing is the most simplest use cases to get us ourselves accustomed with the algorithm itself. So let's start with operational transformation, right? Let me bring up my browser. Cool. So yeah. So yeah. So for us to understand operational transformation, let's try to implement a similar algorithm, right, which is very naive, and and it does nothing extra, right, what the operational transformation algorithm does. So to understand that, let's just imagine that we have a client 1 and client 2, your friend and you, working on a document which has the current text abcd and abcd, right? And there's a central server which is gonna act like a moderator between client 1 and client 2 to sync their state, right? So let's imagine there is two concurrent edit that's going to happen to the document, right? You make a change and your friend makes a change, right? So let's imagine you add a letter E after B. So it's kind of becoming operation of inserting E at position 3. So this is non-zero index, which means the index starts from 1, 2, 3. So at position 3, you are inserting E, and your friend is deleting C, which is an operation of deleting at index 3, and the number of character that got deleted was 1, right? So these two operations that you did on the document, right? So let's imagine the single purpose of the central server is to broadcast the operations that are being sent to the server. It would broadcast the delete operation to client 1, and it would broadcast the insert operation to client 2, right? Imagining that the client 1 and client 2 are applying the operation naively without no extra effort, let's see what would happen, right? So this would apply deleting the character 3 of length 1, it would delete E and it would become ABCD. And the client 2 would apply the insert operation E at position 3, and it would become ABED from ABD. So as you can see, both the clients, you and your friend, are in a divergent state. If they apply the operation right away, what happens is that you end up in a state where you and your friend are having different content of your document, right? Which is against the point of collaboration itself. Cool. So let's make some changes to the algorithm to avoid these cases that we just faced, right? So let me zoom into this also. Cool. So again, we have a similar setup where we have a client 1, client 2, both of them are in the same state, ABCD and ABCD, right? And there are two concurrent edits that goes in, which is again we are inserting E at position 3, right? And the client 2 is deleting C, which is at position 3. One big difference here is that the client 1 is gonna go into a state called waiting for acknowledgement. So acknowledgement here means that the server is telling you that I have got your operation that you sent, and it has been broadcasted to all other clients. That's what acknowledgement means here, right? And the client 1 moves into the waiting for acknowledgement state, and similarly the client 2 sends the delete operation, and it has moved into waiting for acknowledgement state, right? So obviously one of the operation from client 2 or client 1 is going to be broadcast at first. So let's imagine that the central server decides to broadcast the delete operation first, right? It says like send this to all client, where the client 2 deleted character at index 3 of length 1, right? So the central server sends that and sends an acknowledgement to client 2 that what, I got your operation, I have broadcasted to all other clients, right? Now when the client 1 gets this operation delete, it checks what state it is in. It is still waiting for acknowledgement. So what it does, rather than applying the delete operation directly, it takes all the pending operation for which it is waiting for acknowledgement. So it is waiting for acknowledgement for insert E at location 3. So it knows that the other client must have meant not the current third index, it should have meant the fourth index, right? Because you have interest in the client 1 has inserted E at location 3, so the client 2 should have meant location 4, which is C, right? So this is what we call it as a transformation. So whenever you get a new operation, the client checks if it's waiting for an acknowledgement. If it is waiting for an acknowledgement, then it transforms the current operation relative to all the previous operation or the pending operation it is waiting for. Now what would happen? The delete operation gets transformed to delete 4 comma 1, and abecd becomes abed, right? And then the central server is going to broadcast the insert operation to client 2, which is insert e at location 3. Now the client 2 checks its current state. It is not waiting for any acknowledgement. There is no pending operation, so it directly applies the operation, which is nothing but inserting e at location 3. So they end up having abed, and the client one is also having abed. And after broadcasting insert, the client one is going to get the acknowledgement. So after all this back and forth, both the client are in abed and abed state, which is consistent, and they are in sync, right? So this is the heart of operational transformation. So in operational transformation, all the operations are not applied directly, they are transformed if the client one has any pending operation that needs to be broadcasted to other clients, right? So this is what we call it as operational transformation. So you might ask that, like, okay, Ameer, you said it is simple, but the algorithm doesn't seem to be simple, because I have just talked the basic use case. There are other conflict resolutions and more things and nuances that the operational transformation algorithm takes care, right? So as the saying goes, right, for every complicated algorithm there is always an npm package. So there is an npm package which is called Firepad X. So Firepad was initially created by Firebase team to demonstrate how real-time Firebase is. So it's an implementation of operational transformation for you to collaborate on code editors, so that two folks having a code editor can collaborate on the code, right? But at HackerRank, we wanted some more features, and the original Firepad didn't support TypeScript, had an outdated build system, had an outdated API, and it was tightly coupled to Firebase. So we rewrote it from ground up. So it has all the nuances of operational transformation. And if you want to provide two code editors in which two folks can collaborate on, you just use our library and just call this particular method, in which you pass a database refer of Firebase, and then you pass an editor instance, let it be Monaco, Code Mirror, or anything, and then you would have a collaborating code editor between two clients. It can be multiple clients also, but it's not tightly coupled to Firebase or an editor itself. So we have an architecture in which you can provide an editor adapter which adapts to any editor. It can be even a text area, and we have a database adapter which can adapt to any database. It can be Firebase, Postgres, whatever it is, and as long as you implement the database adapter, it should work, right? So that is operational transformation. Cool. So operational transformation, on a brief note, it can sync only text. That is one small disadvantage of it, and it needs a central server. Without a central server, operational transformation won't work. And it is used by products like Google Docs, HackerRank Code Sandbox. So most of the text collaboration that you see on the internet most probably are using operational transformation. And one of the biggest advantage of operational transformation is it is always consistent. As long as all the clients are connected to the internet and they have pretty similar network speed, they should always be in the consistent state, right? So let's dive into another algorithm for collaboration. It is called conflict-free replicated data types, or CRDT. It is also again for collaboration, but it takes a different approach when compared to operational transformations. Cool. So to understand operational transformation, let me bring back the Excalibur. Cool. Cool. So in operational transformation, all the operations were based on indexes, right? That's where there was a need for you to transform the operation that you send to other clients, right? So the CRDT algorithm kind of eliminates it by kind of removing the index from the algorithm itself. So what CRDT does is it assigns a unique ID to all the character in your text. Let's just say you have ABCD in client 1 and client 2. So it start assigning a unique ID to all the characters. So here the 1 is nothing but the client ID. So client 2 has client ID 2, right? And AB is nothing but incremental identifier to each of the character. But this will never change, unlike a index, right? So 1a is always fixed for a, 1b is always fixed for b, and on the other client 2a is always fixed for a, and 2b is always fixed for b, right? Now let's just say there is two concurrent edit coming in, right? So someone inserts e, and here the operations are represented using the unique id. So I say I'm in, someone inserted e after 1b, right? Here we are not using index, we are using the unique id to represent where things are getting inserted, right? Here we say delete 2c, which is the unique identifier of the character to be deleted, and the length of the string to be deleted, right? So since this doesn't involve the index itself, the both the client can independently talk to each other, which can be over even a peer-to-peer communication using WebRTC or other peer-to-peer protocols, and then they can apply the changes that they want, right? So the changes that were sent were, it wanted to insert e after 1b, right? The client can directly after 2b, it can insert e, right? And the delete, when it was sent, it specifically said delete the 2c identifier and the length is 1, so it can directly go ahead and delete c. So right away we end up in a consistent state in which the client 1 and client 2 are having the same text, right? So the idea of CRDT is you don't use indices, so you don't care about transformation at all. You just apply the operation that comes to your to the client, and it is kind of transitive nature. You can apply any operation in any order, and both the client would eventually reach consistency, right? um, So in the conflict-free or CRDT, you can sync more than array, map, and text, which you will be seeing soon. It can do more than text. And in CRDT, the data structure itself becomes collaborative. Text is also kind of a data structure, and in CRDT, it promotes it to array and map and other data structures. And in CRDT, you can have a central server, but it also supports peer-to-peer, which is not there in operational transformation. Some of like we use HackerRank CRDT a little bit in HackerRank, and in Figma, if you the pointers of the, if you see the mouse cursors of the other users, it is actually using CRDT. Jupyter is another IDE which is for data science use cases. It also for collaboration uses CRDT algorithm, right? So with that said, let me take you through the example that I had, right? It is actually using YJS, which is again an implementation of CRDT itself. So there are multiple implementation of CRDT. CRDT is just the algorithm, YJS is an implementation of it, and its implementation is just not just available in JavaScript, it's available in multiple other languages also, but YJS is mostly the reference language. Cool. So let me take you through the example that I had. So we can see here that we have one hook which is called use to do's. Let me zoom in so that everyone can see. So yeah, so it has a single hook called use to do. Let's go into the use to do and see what it does, right? So in use to do, we are getting something called a ydoc from a context, right? So it's coming from a context. So let me have a look at the context. So in the context, what I'm doing is I'm creating something called a new doc from YJS. So in YJS, the data type that you're sharing across clients is called a doc. You can think about it as a shared data structure. So the data structure that you're using in one client is shared to another client over the wire. It kind of feels like magic, but that's how YJS works. So in the YJS, you create a new doc and you connect the doc over the wire. So this is where I'm connecting it to the wire. So I'm using the WebRTC, using the to-do demo as a key, and I'm saying that, okay, connect this to WebRTC, and this is the shared data type that I'm going to use over the wire, right? So that's what I'm injecting here through the context. And then I'm using a method on the shared data structure called get array, right? So this is going to create a new magical shared array and give it back to me, right? So whenever I'm calling the add to do method, what it's going to do is it's going to push it to that magical array. So this is a shared array, right? Remember, so I'm just pushing it to that array. And it also has another method called observe. So using the observe method, you can get to know whenever the other clients are making changes to the shared data structure, right? In that, I'm just updating this to-dos with the current to-dos, right? So I'm just listening to it and updating it, right? So the entire magic lies in creating this shared data type, which is shared over the wire, which is over WebRTC, and just doing all your operation that you would usually do on that particular shared data type, right? So there are other methods also. You can get an array, you can get a map, you can get a text, right? You can even get an XML fragment, which is much more complicated than for complicated use cases. So yeah, so you get a shared array, you do your operation on that, and that's it. So whenever you are adding to the shared array, all other clients are notified about the change and they update in real time, right? So take a simple use case like the mouse pointers of multiple users, right? They are again a shared data type in which it's a map in which you store each user's current mouse position across all clients, and you can easily render multiple users mouse cursors moving around in the screen, right? So that's the power of CRDT. In CRDT, you can do a lot of collaboration by a shared data type, which can be array, map, or text. And the biggest advantage is it's peer to peer, so you can scale little better when compared to central server. Uh, yeah. So now let's take a final look at like what are the quick differences between OT and CRDT. So the operational transformation requires a central server, and for CRDT you don't need a central server. You can do it over peer to peer. And for using operational transformation, you can only sync text, not more than text. And in CRDT, you can do text, array, and map. So in OT, the order of operation is critical. What I mean by the order of operation is like you can apply operation A only after operation B, right, or vice versa. But in CRDT, that is not a requirement. You can apply the operation at any order, and you would end up in a consistent state. Both have their own advantage and disadvantage. For example, the order of operation is useful. For example, at HackerRank, we use it to use the order of operation as a keystroke, so we can give a playback after the interview, like how the candidate wrote code and like how he went about it, and we use it for we can use it for plagiarism checking also, whether the codes were copy pasted and things like that. But we kind of lose the keystroke data when it comes to CRDT, because the operations can come in any order and they are not time stamped. So that's one issue with CRDT. And operational transformation ensures that there's always consistency when, as long as you're connected to the central server, you're always consistent. CRDT always promises only eventual consistency. At some point in time, all the clients would have the same consistent data that they're supposed to see, right? So that's about operational transformation, CRDT, and how we can kind of use existing npm packages and implementation to use this algorithm to build collaboration into your web application. So yeah, I hope that kind of sparked kind of a curiousness that you would go ahead and like think about adding collaboration to your web application. Again, thank you for listening to me, and like let me know if you have any questions in the session that we'll be joining. Thank you, everyone.